Hello and welcome. I am INDRAJIT Chaudhuri, a first year student at IIT Kharagpur, and this is my submission for assignment 2 of the DIY project course Spring 2021-22. I have designed a basic fire detection and suppression system. A fire, under normal circumstances, is accompanied by an increase in the ambient temperature as well as the emission of large amounts of smoke that consists predominantly of carbon dioxide, carbon monoxide, and particulate matter. My device makes use of a gas sensor and a temperature sensor to try and determine if a fire has broken out. Before I go into its working, here's a brief description of all the components used. This is the gas sensor. For practical purposes, we'd use one that can measure the concentration of CO2 or CO. For convenience, I have mapped its arbitrary output to a more suitable scale as is shown here. In real life, it is necessary to calibrate this scale to find out exactly which reading corresponds to a dangerous amount of gas. We arbitrarily assume it to be 15 here. Next is the piezo or the buzzer that emits different sounds depending on the detected hazard. An RGB LED that glows a different color for each situation, 3 possible cases, 3 different colors. The temperature sensor, a DC motor which in real life will be connected to a sprinkler system, and manual controls of the sprinkler system. This is how everything looks like once the connections are properly made. Note that this is the master switch of our suppression system. When switched on, the sprinklers are enabled and ready to be activated either automatically or manually. As soon as it is toggled, the sprinklers get disabled. They will never run in this state, not even manually, and this blue LED glows to alert us that sprinklers will remain off even if a fire is detected. Let's keep this switch on as it should always be kept. Here are the temperature and gas level values as picked up by the sensors, which are both currently normal. Ideally, this should be displayed on an LCD screen, but adding that to our device would complicate it further. Let's first increase one of the two parameters, say the temperature. As soon as it crosses 60 degrees Celsius, the alarm sounds, LED glows yellow. The sprinkler doesn't activate as there is no smoke, which means this is probably not a fire but some other heat source that is nearby. We'd never want water or whichever suppressing agent we have to be sprayed everywhere if it is just a hot utensil that triggered the temperature sensor. A warning is enough, and it quietens down once everything is normal. Now, if the gas level increases beyond 15, with the temperature remaining fine, a similar overall approach is taken, just with a different sound, a different LED color, and a different warning message. Again, there's no spraying as the sensor was in all likelihood set off by nothing more than stray smoke. Now let's say the temperature and the gas concentration have both risen beyond safe levels. Fire alarm sounds, LED turns red, and if the sprinkler master switch is on like we left it, the motor starts shortly after the buzzer went off. The motor continues running until both temperature and smoke fall to normal. Why this small delay between the first alarm and motor start? So that we can turn off the switch if we think it is a false alarm and prevent needless initiation of the suppression system. Blue light indicates that master switch is off and sprinklers are disabled. We can turn this on again after the sensors go back to normal. There is another feature included here, the final scenario. Suppose we, for some reason, wish to turn on the sprinklers. Maybe there is actually a fire, but the detector has been able to sense none or just one of the parameters and hence not deployed countermeasures. In such cases, we simply have to flick this switch to turn the sprinklers on, flick it back off to stop. This brown wire is the extra connection that at any time can be used to run the motor, provided it isn't already disabled by the other switch. So, here's the code which causes this device to run as I explained. We copy it to the Arduino IDE where it is compiled, no errors, just as we had hoped. So that was my project, and here's a recap of the various circuit components. On a side note, temperature and gas sensors, though sufficiently reliable for most domestic purposes, are often not very accurate. To improve this accuracy, that is reduce the chances of a false fire alarm, they are usually accompanied by UV, IR or other sensors in places where incorrect detections can pose much bigger threats. This was again another wonderful experience. Thank you very much for watching.